Good afternoon. This is Com 361's assignment 3 about the driverless car pathfinding. And the first part required me to form a graph of the major cities in the Greater Vancouver area and the Lower Mainland. And that's what I did here. And the way I made this was I went to Google Maps and I checked the distances between like whether you can go from one city to the other without passing through another major city. And if you can do that, then there is an edge between those two cities. But if you have to pass through another major city, then there isn't. So, for example, Hope and West Vancouver, you can go from Hope to West Van, but not directly. You would have to pass through other major cities. And that's why in Hope's neighbors, we don't have West Vancouver. Then the next part required me to build a heuristic function, but the information we were provided was for an admissible heuristic, but there was a bonus part where we could build a consistent heuristic, and that's what I did in my code. So right here, these two functions help me do that. The compute true distances function, basically what it does is it will set the goal node to have a distance of 0. So from the distance from the goal to the goal is 0. And it sets every other distance to infinity. And then it does the Dijkstra's process where eventually, after this function finishes running, it will give me the distance from the goal node to every other city or every other node in the graph. And in the compute consistent heuristics function right here, we will get those distances from the goal node to every other city. And then for every city in the two distances, we will calculate the heuristic. And this right here was the information that we were actually provided in the assignment initially. So what this does is it will just give us back an admissible heuristic. Then what we do is we will build a graph with the adjacency list right here. And now this is where we change the admissible heuristic to a consistent heuristic. So while we no longer change heuristics, what we do is that for every U in the graph, so for every city in the graph, and for every neighbor of that city, if it is not consistent. So the formula for consistency is HU needs to be less than or equal to cost plus HV. But here we're saying that if it is not that, then replace the value to make it equal to and set change equals to true. And eventually by when this finishes running, we're going to have consistent heuristic. Then the next part is like I've defined the A star search algorithm here. I've defined the Dijkstra search algorithm here, and I've defined the Grassfire search algorithm here. And then this is just the Pathfinder part. So I will run this code now and we will see how to move from one place to the other. So let's run this. That is just me testing things. So I'll just clear and then we can run again. Uh, let's say that we want to go from, let's say we want to go from West Vancouver to Abbotsford. So AB. And let's say I want to use A star. So this is the route that we will need to take. So we need to go from West Van to North Van to Van, Richmond, Delta, Surrey, Langley, Abbotsford. That is how it also is on Google Maps. And let me run this again. And let's say that I want to go from, let's say Hope to New Westminster. And let's say I want to go using the Classifier algorithm. So I'll have to go from Hope. So the neighbor is Mission, then Mission to Abbotsford, then Abbotsford to Langley, then Surrey, then Delta, then Richmond, then Vancouver, then Burnaby, and then New Westminster. And let's say I want to go from New Westminster to, oh, I need to run that code. Let's say I want to go from New Westminster to, let's say Chilliwack, and I'll use Dijkstra's. So we have the same thing. So basically, it was the same thing, but kind of backwards. It was New West, Burnaby, Vancouver, Richmond, Delta, Surrey, Langley, Abbotsford, and then Chilliwack. So yeah, that is my assignment 3. And then using these 3 search algorithms, so A star, Dijkstra's, and Grassfire, you can move from one city to the other. And for A star, we were going to use a consistent heuristic. Dijkstra is a bit more greedy, so it does not really use heuristic where it takes cost into account, and Grassfire does not take cost or heuristic. It just follows the number of steps. It's a BFS, breadth first search algorithm implementation. Thank you.